The first area of confusion that we'll address revolves around the use of closures in Spark. Although, we'll first make sure we have a basic understanding of what closures are. The simple definition is that a closure is a standalone function which contains at least one bound variable. However, I think an example might act as a better explanation. So, I've preloaded code that counts the items in a list as our example. The first thing we do is instantiate our counter variable, which will end up being our bound variable. Then, we create our list and call its forEach method. The forEach method takes a function as its parameter, one that expects to receive each item for which it'll do some stateful action. The function that we pass takes our count variable and increments it for each execution or item encountered. It also prints the new state of the variable. Then, we end with a println to verify the final state of our count variable. Pretty basic, right? Okay, so can you spot the closure? It's the function passed into forEach. Notice that it never defines a count variable. That was done outside of the function block. Also remember, this is a function object, which could be executed either eagerly or lazily, meaning it could be executed after the originating method has completed. So, considering that to be true, how can the count variable still be in scope for use? The short answer is that the function closes over it, trapping it in a more global scope, thus the name closure. In this case, the execution is eager and our count works as expected, where the totality of the updates made to our closed over variable are indeed reflected in the final output outside of the function, as both the closed over count and the one from the originating method are ultimately referencing the same object. Now, mutating closures like this come with some possible perils surrounding order of operations and other problems you might run into, just the same as with working with global variables lazily or in parallel. So, while closures offer some decent programming power, they're often better left for use with immutable variables. However, if you do choose to mutate these variables, it should be done very cautiously, so as to avoid headaches further down the road. Now, with the basics of closures covered, we can cover a common misconception revolving around using closures inside of Spark. Here, I've recreated our item counting example, with the only change being that we're using an RDD collection instead of using the core collection directly. I've also explicitly set the RDD to have 5 partitions, so as to better exhibit the problem. And what is the problem? Well, running the code, we can see that it does not work as expected. First, we can see that the output from inside the function is no longer a continuous count, but instead a series of 1s and 2s. Then, our final output isn't the expected 10, nor is it even the 1 or 2 we were seeing. It's still 0. What's going on here? Well, remember, Spark is distributed, and variable references do not inherently cross node boundaries. So, what's happening is that each partition is getting its own copy of the variable. Partition 1 gets a count variable set to 0, as do partitions 2 through 5. Then, each gets a certain portion of the data to which it runs its own version of the function. In this case, the data is distributed evenly across all partitions, with each getting 2 items. So, each partition updates its count variable to be 2. And, since all of this is happening outside of the driver, then its count variable is never even updated, leaving it in its original state of 0. So, as we've shown, although more of a warning normally, mutating trapped variables in a distributed system such as Spark is never a good idea. Now, in some older versions of Spark, if Spark was running as a client, local only, then this would seem to work since the variables were shared across the same JVM instance, which caused even more confusion, as the local code acted different than when it was distributed across the cluster. But more recent versions now have a consistent behavior no matter how you run the code, at least eliminating that confusion. And now that we understand the problem, how can we fix it? Well, for this specific example, we can use the built-in count methods. But should our logic be anything more complex, then you'll need to use reduction methods, like the reduce or aggregate ones. Or, in cases where you want to return two different values from the same execution, then you could opt to use an accumulator. Here, to keep our example consistent, I'm only returning one value in this updated item counting code, which uses an accumulator and also drops the print statement, as accumulators are write-only on the workers. Then, to retrieve the final value from our driver, we use the accumulator's value property. And running it, you can see that our final value is back to being the 10 that we expect. Next, we'll see another possible issue surrounding closures.